Today we'll talk about a calculation done to matrices called determinants. These calculations are done only to square matrices, which are equal row, equal column. And at this time in your mathematical careers, this is all we're going to be doing with determinants, is doing a calculation. The applications will appear later in your mathematical careers, and I'm talking, second year college if you go into a math science field. But for right now, it's just going to be a calculation. Notation for determinants, it looks kind of like an absolute value, or they'll put a DET out in front labeled determinant. To calculate that determinant, you take the diagonal of A and D, you multiply those together, and then subtract from it the diagonal multiplication of C and D as shown in this example. If we do the actual example, again, we take this diagonal of -9 and 5 and subtract from it this product of 6 and 1, getting -45 minus 6 or -51, and it's strictly a number, which at this point is not going to mean a thing to you. Moving forward, we can do some other applications where we have expressions within the matrix. So when we take the determinant, again, there's those absolute value signs. Now we have a product of two binomials, so we have x plus 7 times x minus 1 minus 7 times 5, or 35, is equal to 0. So we have x squared plus 6x minus 7 minus 35 is equal to 0, or x squared plus 6x minus 42 is equal to 0. And I don't see that factoring, so I'm just going to take and complete the square on that. And I get x squared plus 6x plus 9 is equal to 42 plus 9. So that's x plus 3 quantity squared is equal to 51, and x plus 3 is equal plus and minus the square root of 51. So x equals -3 plus or minus the square root of 51. So in terms of a 3 by 3, there are a couple of different ways to do this. I think the book shows one way. I'm going to show you this way because it's a little bit easier. This way will only work for a 3 by 3 matrix, though. The book's ways, you can apply the concept at least to 4 by 4, so on and so forth. But if you don't move on to math science area, showing you that way is not going to be necessarily appropriate or easier for you. So let's just take and do it this way. So when I have a 3 by 3 determinant to do, what you basically do is take your original matrix, copy the next two columns, or the first two columns down next to it, and then you'll notice the series of arrows going down diagonals. What we're going to do with each diagonal is we're going to multiply the elements in that diagonal together going to the right. And when I talk about a diagonal, I'm talking about a full diagonal of 3. So we multiply each of those diagonals and then add their products together. Now if you'll notice, with this blue arrow going this way, there's 3 more diagonals of 3. And we'll multiply those products together too. But since they're going to the left, we subtract all of those values. And you can see that the determinant is made up of the sums of the diagonals going to the right and the differences of those products of diagonals going to the left. Let's do a problem for an example. So once again, I'll copy down the first two columns. Try to keep your spacing evenly so you can see those diagonals. I multiply this diagonal, which gives me a 4 times 1 times 3. I'll just multiply everything out. This diagonal, and again I'm going to add those because I'm going to the right. So this is 2 times 1 times 2. multiply this final diagonal, which is negative 1 times 5 times 0. And then I'm going to subtract the diagonals going to the left. So this is negative 1 times 2. Again, I'm subtracting these. This is minus 4 times 1 times 0. And then last is minus 2 times 5 times 3. Clean this all up. We end up with 12 plus 4 plus 0. This is going to be a plus 2 because I have minus a minus. Minus 0 and minus 30. Further cleaning gets me an 18 minus a 30, which is negative 12. And that's all there really is to finding determinants of 2x2s and 3x3s.